Uh, hey everyone, today we are going to break down CI/CD, specifically looking at how to implement it using GitLabs and Kubernetes. We'll start with the basics, look at the architecture of pipeline, and finally discuss why modern DevOps is moving toward a GitOps model to solve security and scalability issues. Let's dive in. First slide. Uh, First, what is CI/CD? It stands for continuous integration and continuous delivery or deployment. CI, continuous integration, is where developers push code to share repository. That code is automatically built and tested to catch problem early rather than waiting until production. CD is continuous delivery or deployment, takes over after testing. It's ensuring code is ready for any environment. In continuous development, if the test pass, the code goes live to a user automatically. Simply, CI checks the code and CD delivers it. Okay. Um, for this guide, we are focusing on GitLab. Why? Because it's all in one DevOps platform. Instead of stitching together 5 different tools, like one for Jira, one for GitHub, or one for Jenkins. For CI/CD specifically, it's powerful because your pipelines are defined as code using a YAML file right in your repository. Okay. Um, Before we look at the flow, we need to know where our application lives. This is a container registry. Think of this as a library for your application's building blocks. When your CI process builds a Docker image, it needs a secure place to store it. GitLab has a built-in registry. We push the image there, and later architecture tool like Kubernetes pull the image to run the app. It creates a secure versioned history of your software. Step 1, it's automated. So it's a life cycle of code change. In step 1 is automated tested. This is the heart of process. Before any code moves forward, we run unit tests and listing to check for bugs and enforce coding standard. Crucially, if any tests fail, the pipeline stops immediately. This prevents bad code from ever reaching the next stage. Step 2 is build phase. Once tests pass, we created the deployable artifact. We package the application into a Docker image and tag it with a unique version number. We then push this image to the Container Registry we talked about earlier. The result is an immutable artifact that is ready to run anywhere. Step 3 is deployment. This is where the application reaches the user. Kubernetes steps in here. It pulls that specific versioned image from the registry and updates the application's paths. Once the update is complete, the new version is live. This cycle ensures user always gets the latest stable version efficiently. So how do we configure this in GitLabs? It starts with the pipeline. A pipeline is a blueprint for your entire process. From commit to deploy, it automates the sequence of events. Pipelines can be triggered automatically when you push code. When you open a merge request or even manually if you want to control a production release. Pipeline are broke down into stages. Okay, this requires logical phase like test, build, and deploy. The rule here is sequential success. The build stage won't start until the test stage finishes successfully. This ensures dependencies are met and we don't waste resource building broken code. Slide 9. Okay. Inside those stages, we have jobs. Jobs are fundamental units of work. The actual task like run unit tests or compile code. A massive benefit here is a parallel execution. If you have multiple jobs in the same stage, like running front-end tests and back-end tests, they can run at the same time, significantly speeding up your pipeline. Okay, the workers. Okay, who actually execute these jobs? That's the GitLab runner. GitLab itself is a manager, but the runner is the agent that does the heavy lifting. Runners are flexible. They are the virtual machines, or more commonly today, they run inside Docker container or Kubernetes cluster to ensure a clean environment for every single job. Let's look at how runner works specifically in Kubernetes cluster. The runner exists as a pod in your cluster. It pulled GitLab for jobs. GitLab never pushes jobs to it. When a job is assigned, the runner creates a temporary pod just for that task. It runs the test or build, and as soon as it's done, that pod is deleted. This creates a high degree of isolation and scalability. Next slide. Here, architecture diagram. Here is the full architecture visual. You see a GitLab runner here. A GitLab runner in the middle. It pulls the GitLab server periodically. When it gets a build job, it spins up a pod, builds the code, and pushes it to the registry on the right. When it gets a deploy job, it asks the Kubernetes control panel to schedule the new application paths. It's robust system, but it has flaws. Okay. This is the traditional CI/CD flow, but it has problems. One is security. Your CI pipeline needs a full access creation to your cluster Kubernetes. If your CI is compromised, your cluster is compromised too. Configuration drift. If someone manually changed the cluster using kubectl, the CI pipeline has no idea. The state in Git doesn't match the really in a cluster. Rollbacks. Rolling back usually means rerunning an old pipeline, which is slow and manual. Okay. This brings us to GitOps. In GitHubs, we use a tool like Argo CD. Instead of the CD pipeline pushes changes to the cluster, Argo CD sits inside the cluster and pulls changes from Git. GitLab CI is still used, but only to build the image and update the manifest file in the repo. It has no cluster access. Argo CD watches the repo. When it sees a change, it automatically syncs the cluster to match. Benefits. Let's talk about benefits. It dedicates drift automatically. It's much more secure, and the rollback is as easy as Git revert. This is a modern cloud native best practice. Thanks for all you watching.